Hey everyone, today we're going to talk about solving absolute value equations. So an absolute value, as you can see, has like two little bars around an x. So what this stands for is the absolute value means the distance a number is from zero. So for example, if I did like the absolute value of negative, let me think about this, hold on. If the absolute value of x equaled 3, they're saying what is the distance of 3 from 0, or what numbers are a distance of 3 from 0. So if I look at this on a number line, we've got 0. If I go 3 this direction, 3 is a distance of 3 from 0. But also, if I go 3 this way, that's a distance of 3 from 0. So both 3 and negative 3 are a distance of 3 from 0. So the numbers that x represents can both be negative. So x is negative 3 and 3. But this distance number should be positive because a distance is always positive. So both of those are a distance of 3 because you can't have a negative distance. So these numbers should be positive, but what it equals, but like what the x represents can be negative. And we'll see that more in these examples. So your first step when solving is to get the absolute value by itself. So if I wanted to get this absolute value of x by itself, I'm first going to move that 5. So I have absolute value of x equals 8. So 8, if I look on a number line from 0, if I go 8 units to the right, I hit positive 8. And if I go 8 units to the left, I hit negative 8. So our solutions, we've got two solutions. So x is going to be positive 8, and x is also negative 8, because both of those are a distance of 8 from 0. Next one, again, we want to get absolute value by itself, so we subtract 2. So absolute value of x equals 7. So I think about what are the two numbers that are a distance of 7 from 0. So they are positive 7, and negative 7 is also a distance of 7 from 0. Next one is a few different parts. So we're first going to add the 4 over. So we've got 2, absolute value of m equals negative 2. So the 2 is touching the absolute value. So right now that means multiplying. So the opposite of multiplying is dividing. So we would divide by 2 to get rid of it. Ooh, so this one looks kind of special. So we've got this negative 1. So the absolute value is negative 1. So when you have a case like this, it is actually no solution. So the reason for that is because your absolute value cannot equal a negative number, because the distance from 0 can't be negative. So if you ever have the absolute value equals a negative, it's no solution because distance can't be negative. All right, let's look at another one. So number 4, the absolute value is already by itself. There's just stuff inside of it. So we're still going to split into two parts. So we'll have x minus 4 equals positive 10. So that's 10 from 0. And then x minus 4 is also negative 10 units from 0. So we take the whole thing, we split into two parts and do the positive 10 and a negative 10. And then we solve both of them. So I would add 4. So x equals 14 is one solution. Here I would add 4 as well. So x equals negative 6 is my other solution. So on all of these, we are going to get two solutions. So why don't you try the next one before you watch it. So again, we split it up, and we set it equal to the positive 3 and the negative 3. And then we solve both. So our first solution is x equals 2. And our second solution is x equals negative 1. Okay, on the next problem. So I know that sometimes we want to distribute that negative 3. However, absolute value symbols are kind of like bars that are trapping what's inside of them, and nothing can penetrate inside. So you cannot distribute. So instead, because it's touching, we're going to do the opposite of multiplying, and we're going to divide. So we've got absolute value of 2w equals 4. So notice originally it equaled a negative, but because we divided by a negative, now it's a positive. So this works. So it can be a distance of 4 from 0. So we'll have 2w equals positive 4 and 2w equals negative 4. And then we can divide by 2. So w equals positive 2 and w equals negative 2. All right, let's flip to the next page. We only have a few more to go. So again, we cannot distribute. Can't distribute. So instead, we divide. So instead, divide. So on number 7, if I want to, I can't distribute that 4 because the bars are trapping. So I'm going to divide by 4 because the opposite of multiplying is dividing. Equals a positive, so we're good to go. We can split it up. So y minus 4 equals positive 4, and y minus 4 equals negative 4. So y equals 8, and y equals 0. I know we don't usually like when y equals 0, but it is an okay solution. Ooh, number 8 has a lot going on, but again, our first step is just to get the absolute value alone. So we always move what's being added or subtracted first. And again, we can't distribute the 2, so we have to divide. And now our absolute value is alone, so we can split it up. So we can add 2, so 3x equals 5. Dividing by 3, ooh, you can't do 5 divided by 3. It would be a decimal, so we're going to leave it as a fraction, 5 over 3. Over here, we've got 3x equals negative 1. Oof, again, we can't divide negative 1 by 3, so we're going to leave it as a fraction. Number 9, again, we need to get the absolute value by itself, so we're going to subtract 12. And then divide by 3 because we can't distribute it. Ooh, our absolute value equals a negative. So as soon as the absolute value is alone and it equals a negative, that's when you can stop and say no solution. Because again, the distance can't be negative. So the reason for that is because it equals this negative number, and an absolute value can't equal a negative number. All right, only 2 more. So we want to get absolute value alone, so we can add 6 to both sides. Divide by the 3 to get rid of it. All right, so this one equals a positive, so we're good to go. So we can split it up. So 5y minus 7 equals positive 10, and 5y minus 7 equals negative 10. So we can add 7 to both sides. So 5y equals 17. Divide by 5. Oh, we're going to get another fraction, so you can't divide 17 by 5, so it's going to stay 17 over 5. Here add 7 again, so 5y equals negative 3. And again, can't divide negative 3 by 5, so it stays a fraction, negative 3 over 5. Those are nice because you don't even have to type them into your calculator. You just know that that's not possible, so you leave it as a fraction. All right, last one. So we've got plus 3 plus 3. So 5 times the opposite value of negative x plus 7 equals 9. Divide by 5. Oh, all right. So we've got an absolute value equals, you can't divide 9 by 5, so it's going to stay that way. So that's positive, so it's okay. It's good to go. It just looks kind of gross. So we're going to split it up into negative x plus 7 equals 9/5, and negative x plus 7 equals negative 9/5. So we'll do a minus 7, minus 7. So those yellow calculators are really nice because you can use the fraction button. So the fraction button looks like n over d. So that's what you should be looking for in your calculator. And if you use that button, you can type in 9/5 minus 7, and you're going to get negative 26 over 5. Ooh, and then since x is negative and the other side's negative, if you think about dividing both sides by negative 1 or multiplying by negative 1, it's going to switch the signs of both. So we're left with a positive 26 over 5. Other one, still subtract 7. So again, you probably want to use that fraction button on your calculator. So when you type that in, you're going to get negative 44 over 5. Again, both sides are negative. We want x to be positive, and that changes both sides to be positive. So we're left with 44 over 5. All right, those are your absolute value notes. Good luck, and I hope this helped.